My name is Kolja. I'm also working at itemis. I'm working with MPS for now roughly 8 to 9 years. Started back with version 2.0. We were basically no set transformations and stuff like this, and you had to type AST. And built with the other guys at itemis basically embedder, and this was my way into MPS. And yeah, lately I'm doing lots of customer projects where we build custom DSLs for various domains. And what I'm going to talk about today is how do we actually build these DSLs, not necessarily from a perspective of MPS. There is a section about MPS, how it enables us to do that. But more from a perspective, how do we actually get to a DSL that fits to the domain? So is it big design up front? We sit down, look at the domain, basically analyze it for a year, and then come to the conclusion, this is the DSL for it, we build it, ship it, and as we are also good software developers, there are no bugs. Well, the obvious answer to this is no, right? So, how do we do it then? If we don't sit down, just look at the domain in one big step, ship one language when it's done, and then we have the perfect tool for our users. So, let's take a look at an example from the real world. So this is a wheel lock wrench, it's called in English. In German we call it Radkreuz. It's used to actually untie the screws on the wheel of a car. And this tool is quite generic. It doesn't require any energy, it doesn't require electricity, it basically works everywhere. You can do this in a snowstorm at minus 30 degrees as long as your hands don't freeze. But you can also just use it at a local workshop, or you can use it as a production line for assembling cars. And this might work well if you just change your summer or winter tires once a year. It might also work if you work at a workshop where you have to unscrew 4 or 8 wheels a day. But what about if you are at a production line for cars where you would have to screw 40 wheels an hour because you are producing 10 cars an hour? So then you most probably want to have something like this. So this is a picture of one of the assembly lines of our customers, where there is like a thing. This is a robot arm where it's operated by one person. It carries the complete wheel, and it can basically attach the screws for the wheel in one step. It does it in the right order, with the right torque, everything. But it will only work basically at the assembly line, so you can't use this somewhere else. But it's specifically tailored for this use case. So how do we get from A to B in this case, right? So how did we get from this very basic tool that basically works everywhere, which might be your C language, to the very specific one that does one use case very good, reduces errors because you can't use the wrong torque for the individual screws. It tightens them in the right order. It knows which kind of wheel it's attaching, so it also knows what the required torque is, etc. So most probably it isn't a straight line there, right? So we haven't had the manual tool in the beginning, and then at some point somebody had the idea, oh, we need this because this is exactly what fits the needs at the production. So it might have been, so how did we actually get there? So through iteration in increments. So we, I don't know the exact history of how we got to this robot arm that is used at this production site, but I might have to do something like this. So at the beginning we had the very basic tool where you have to do everything manually, where you have to feel if the torque is right, etc. Then the next step might have been a tool that can actually tell you how much torque you applied, so you don't apply too little or too much torque to the individual screws. And then the next iteration might have been where you don't have to do any manual work anymore. You have one thing that can basically automatically screw and unscrew one part of the screws on the wheel automatically, and then maybe from that the last iteration was to get to the very specific tool that is now used at the assembly line. Or maybe it has looked something like this. So there might have been various branches that were dead ends, so where people tried out different kinds of tools, and then they decided that some of these weren't actually worth pursuing. This is essentially how we now also build languages. So we try to build them in iterations, in small steps, so that we can actually get feedback on the things that we build, We try to ship them as early as possible to our users so that we get feedback. So where did we apply this? I'm just taking 3 of the bigger examples from the recent past. So this is basically based on the experience of the last 4 to 5 years in various domains. The biggest project is basically a systems engineering tool for modeling the distributed architecture of a car. So this is the current project I am involved in, and we basically describe the complete software and hardware architecture for cars there. We have there over 100, 150 users, and we ship every 3 weeks. So we ship a new language every 3 weeks, and over the past 2 years we have done 42 releases. And we really keep a tight schedule of 3 weeks. We ship something, we get feedback, and we incorporate it. Then we have also applied this to various degrees in a project where we had a DSL for calculating social benefits. So the law in Germany for this is quite complicated. And we also did something there, and some of the findings are also from this kind of project. And last but not least, we also applied this for embedded software development tools, where it's about generating code for various different domains of embedded code generation. So why would we do this, right? Why would we do this in small steps and not in one big release that we do once and then everything is solved? So basically, we want to get feedback early because in most of the cases, we might not be 100% sure what the solution in the end will actually look like. So we want to pursue some idea that we have, and we want to validate it with our end users. Then we might also want to explore the domain step by step, right? And I don't mean this in getting feedback on the same idea, but also focusing on different aspects of the domain at different times in the project. So that we can focus, for instance, maybe on the core language that is used to calculate the taxes or the social benefits, but leave alone some other aspects of the domain, maybe like how do we handle parameter data, or how do we handle changes of the law over time. Maybe at first we want to validate if the language that we have for actually calculating something is what our end users really understand, and we find this. And when we have done that, we might want to shift to something else and introduce then new concepts to our users so that they over time learn new things and they are not overwhelmed by one big thing. And we most probably also want to terminate dead ends quickly. So we don't want to spend lots and lots of time on something which our end users might not need. So maybe they have a requirement to do something, a specific part of the language, which is quite expensive to build in its full blown implementation, but the users might discover early that this is actually not what they need, that this aspect is no longer valid for what they are doing. So we also want to have this feedback early so that we can decide what parts of a DSL we would actually like to focus on. So I talked about this distributed car architecture modeling tool for systems engineering. And there, for instance, at the very beginning, our end users wanted to have a simulation of the Ethernet that is running in the car, and it was super important to have this. And that they wanted to have output from our modeling tool directly into the simulation tool, get the results back, etc. But at some point, they noticed that at that point in the development cycle, where they actually specify some parts of the model, it's not necessarily relevant to simulate the complete Ethernet because they might not even know how the final Ethernet of the car looks like. So we got early feedback then from other stakeholders in the product that said, this is completely irrelevant for us because there is no network at the moment where we can simulate. So basically efforts could be shifted from integrating a simulation tool to building other features of the language early without spending too much time on it, because we shipped it to our users and they gave us feedback that this is actually not what they want. So if we do this, if we build our DSLs in an incremental way, so what are the challenges that we actually have then to build our languages? So, or not only languages, but overall tools that we ship, right? Because we don't actually only ship languages. We ship most probably a full-blown application to our end users that is not just a set of MPS languages, it's a Chrome, there's integration with other tools, etc. And I will talk about now mostly about these challenges and how we address them, and what challenges we actually identified over the past. And the first aspect where I will talk about is how this kind of incremental shipping and building of our languages actually influence the language design itself. So what did we do different in our languages so that it could help us to build things incrementally, to get feedback from our users, and to also be able to evolve these languages over time, so that it's not one thing we ship once, but that we can actually evolve the things over time. And the first thing is embrace feedback. So really build your languages in a way that users can give you feedback. And the easiest thing to do there is allow comments. It might sound totally trivial, but having comments for end users is a really good thing to express if something doesn't work, right? They can just add a comment, especially if you support rich text formatting or something, where they can actually write down what their use case was, what they expected, and why it didn't work. And they can do this in the model, in the tool. They don't need to open Word, copy a screenshot, annotate something. They can really take your language, and inside the tool they can actually comment on the things and give you feedback. And then just commit it, share the model with you in whatever way you do this. And you, as the language developer, can use this to get feedback from your end users in a very, very good way. So maybe even if your domain doesn't necessarily require you to have comments, because it's a very declarative language, and you think you don't need comments to explain it, enabling comments can allow your users really to give you very good feedback directly in the tool. Then, of course, you can integrate like bug reporters, things like this in the final application or tooling that you ship to your users, like integrating a Gyro bug reporter or replacing the JetBrains exception reporter with your own. All these kind of things you can do. This also helps, but it's, I think, a magnitude less helpful than actually only comments, because this was really a thing. Domain experts could comment how they would actually envision this specific use case and what it should mean. And if the DSL was wrong doing something, maybe the interpreter was wrong, the code generator was wrong, they could just add this directly to the place where they found it. And very obvious, talk to your users. I mean, talk to them, right? Have a structured way of getting feedback from them. Meet with them every 3 weeks, present what you did, so that they actually get to know what you built, and that they can give you direct feedback. So, yeah, don't be afraid of your users. And then, this might be a bit controversial, the level state. And what do I mean by that? So we as MPS developers, I think last year we have seen this usability paper about the safer language that was presented. And one thing there that right after we saw this struck us in the project was people would just leave the model in an illegal state. If something was red, they didn't care. So at least some users, right? So they had a structured editor in MPS. We as developers love it. You cannot express something that MPS doesn't know inside of MPS, right? So you don't have to deal with it in any way. In a parser language, your text might not be parsable, but still somehow your parser has to deal with it. In MPS, we don't care because we have our underlying AST, and if no transformations, no concept to represent it, users cannot even enter it. And from a developer perspective, this is awesome, right? But from a user's perspective, this might not be the thing they want. So especially early in the development, it can be helpful if you allow in your language to express something that the language cannot really understand. So one example might be you have a configuration of a generator. So what's the output format for a specific concept of your DSL? And maybe you have identified 3 different things that the domain experts say you want to generate from this. But you aren't necessarily sure, so it's the first situation where you ship this to your end users. So one thing to do there could be just allow a 4th option, which is free text. So they can just enter something. There will be a warning that you cannot generate code from this. Give them feedback that this will not work in the end, but they can at least express it. And then they come to you and tell you, okay, we have this input model with this specific case, and then we need this fourth option. And they can even explain to you what the actual constraints would be to allow this fourth option. But if they cannot enter it, the only feedback you will get from the users is the tool doesn't work. This is really something, if they cannot express it in a tool, they will often just say, the tool doesn't work, it doesn't allow me to do it. But they will never tell you what. So, especially in early development and in early iterations of your languages, it can be really helpful to have options that your meta model doesn't understand, where it's just a string, but at least the users can interact. Then the next thing is explain why something is not valid. And this is the constraints versus checking rules story, I would say. So, of course, in MPS you can write your constraints in a way that the user can never enter something that is illegal, and it will never even show up in code completion, which is awesome because the user can never enter it. But the user might want to enter it at some point because your constraints are wrong. Or the user wants to know why it's not allowed to enter it at this place. So, in many cases, also especially early in development, it can be favorable to have your constraints relaxed in the constraints aspect of your language. But implement a checking rule that tells the user this is not allowed because other parts of the model are configured in a way that this state is illegal now. But at least they discover why it's not allowed. And then you can also add, for instance, ways to fix this problem directly for the user. So the user enters something that is not valid, a reference points to something that is not in scope. Why not have an intention or a quick fix on this error message that would actually change the part that you are referring to a state where it's valid to refer it. So the user immediately gets feedback what to do to get rid of this error. Yeah, and one note to quick fixes, don't set them to Modular. Yeah, then make new features discoverable. So ways to do that is basically having intentions, having checking rules on info level, basically that there is a new feature that you can use at this specific location. Make it as optional parts of the editor. So maybe you introduce a new feature that later on you would put in the inspector, but that users can actually discover that it's there, put it in the main editor, but make it as an optional thing, or add an intention that they can add these kind of things. Use the context assistant kind of thingy that shows these boxes. Use context actions, for instance. These kind of things you can do to make your features discoverable and, of course, present your stuff to the users, right? So don't just ship your release, make a short presentation about what you did so that you can also get feedback, but they also know what's new to your languages that you actually baked. And then also deprecate dead ends softly. So if you discover that something is no longer really required because your domain experts tell you this is not what we want, there might still be models out there that use it. So if you just remove the language or the concepts, these models get invalid immediately. So the strategy that we typically do there is we first get feedback, maybe with a checking rule, telling that this is a deprecated concept they are using. Then the next iteration, this warning, is getting to an error, but the language is still there, so the models are still understandable by MPS, so the meta model isn't changed, the language is not removed. And then, after the error is there, the concept might be gone 2 iterations later. But when the error is there, we also provide maybe intentions to delete the concept or to migrate it to things that are replacing it. So the users are actually aware of that there is something going on with the languages and that something will be gone that they are currently using. And in these error messages and warnings, you can also tell why it's gone, maybe point them to some location where the relevant discussion was there or to some documentation, etc. And then, the most important thing, don't break existing models. Users will get frustrated if you remove a language, a concept, etc. without telling them earlier. So it's basically in the same direction as what I said before. But really, this is really important because it breaks users' trust. If you remove something in one release without telling them before, they will be frustrated. And they also can't give you feedback because you might have had a discussion with some parts of the domain that say we don't need this, but others think it's still fundamental or haven't followed the discussion. They want to give feedback on this decision, and they can't if they don't know. And of course, if you have decided to remove something, then you can use the automated model migrations of MPS to just delete the existing instances of your concept. Or if you have something that replaces it, and you're not able to do this automatically because there might be some cases where there are basically two choices that the user could have to replace something. You can also provide manual migrations. For instance, intentions, where you present the user that this is, you can migrate this to the pattern A or to the pattern B that would replace this. Or refactorings, etc. So the normal ways that you can give to users to automatically apply some refactorings to the language. So this is it about the actual language design, where we talk about maybe one language, but our system might actually consist of multiple languages, right? So we don't build one big language to represent all of our domain. So we want to build modular languages for the different aspects and facets of the domain, so that you can evolve them individually. So, yeah, this is basically what I just said. So we want to build modules of languages that represent individual aspects of the domain, and they are most probably independent of each other. That doesn't mean they don't have dependencies at some points where it's necessarily, right? You need to integrate this somehow. But still try to build independent modules so that you can evolve this independently. So, yeah, it also allows you to develop them independently. You can focus on one aspect at a time, because your development team might not be big enough to support all of the domain at the same time, or your end users or your domain experts cannot cope with basically explaining you everything at the same time. I mean, it's not only about if you have enough people to build it, it's also if the people who know what you should build can give you the right input. So you can basically decouple these individual aspects, and then these different parts can also have different maturity levels, right? You can have a core part that is very stable, that doesn't change, it's your core expression language maybe. And then there are other parts that are still in a very more beta fashion, and they are individual languages. So if a user doesn't use the language, they will not even see that these concepts are there. You can tell specific user groups that they should use a language that might not be as mature as the others. And it can really help you to decouple these individual development cycles from each other. And then, as I said, you can also explore the domain iteratively in steps. So you can add more value over time by focusing on the different aspects of the domain. And maybe adding more syntactic sugar, more abstractions for specific use cases later on, but at first your users will be able to at least express what they need. It might not be as efficient as they want to have it in the end, but they can use your tool and you can focus on the individual steps one at a time. Okay, so if we have modular languages and we design our languages for feedback from our users, what else should we do? So we should automate. In development is one aspect. So if you build your languages, automation can help you a lot. And one key aspect is you want to have access to real-world models. You don't want to just use examples, because your examples are most probably built by developers, and they will be like the 80% case, which always works, because this is what they built, right? So they built an example with this. You might have one domain expert putting their examples into your system, so it will always only focus on this thing that one of the domain experts has in mind, but the other 90% might not be involved at all. So really have access to real-world models so that you can automate against this. So one thing is run the model checker in the build, for instance. So simple thing, just in CI, run the model checker on the existing real-world models if your changes to the language introduce new errors or warnings. And if they introduce errors, check if they are really valid or if you have an edge case that you didn't cover, so that you get automated feedback. Yeah, of course, you do tests, unit tests, whatever, testing your generators, etc. One thing we also did is we applied migrations automatically. So we used the real-world models in the CI. We applied all the language migrations that we are about to ship to the real-world models of the users, run the model checker again, and see if there are new errors introduced or not. And of course, you can use the migration testing facilities of MPS, but it's once again not real-world models, so it's much, much better to do this actually on the real-world stuff. And then, last but not least, and I think this is really important, automate as much as reasonably possible. So, and reasonably is the important part here. So if you are a small team and the models that you have are small, you might not want to actually automate that much, but if you have a large product that you build, you might want to automate more. So in this case where we do this automatic migration testing, for instance, this is for models that are built by over 100 users. So there we actually saw value in automating. If it's something where I have 5 users and I can talk to them every day, this might not be worth doing it. But the code base of the models that our users use is so large that you couldn't manually just go there, apply the migrations, run the model checker, and do this. This would just be too cumbersome, and none of the developers would do it. But when CI does it, and you don't have to care about it, then people see value in that. And then also, not only automate for the development, but also automate for your users. So give them continuous integration and continuous delivery. So really apply the same things you do for software development to the things that your users build with your tool. So allow them to have a CI job that generates their models, that runs the model checker on them, that interprets it, that runs the test cases, they write in the DSL so they get immediate feedback. And give them a way to get fast feedback from, quote, production. So if you have something where you have calculation rules that you then deploy into the production system, have a meaningful way of getting feedback from there. Maybe performance metrics. So if the things they do with the DSL makes the calculations faster or slower, or if there are more errors introduced or things like this. This is not only useful for users, by the way, this is also useful for you as developers, but it also helps the users. And yeah, check the whole project in CI, so this also helps users, because sometimes they might change. If you have models that allow you to reference things from different locations, and you have cross-dependencies between the individual aspects of your DSLs, so maybe you have one part of your DSLs allows you to describe data types and interfaces, and the other part of your DSL allows you to define software components with ports, where these ports use the data types and the interfaces. And you change an interface that introduces errors on a component, the person who changes the interface might not know, because they won't run the model checker on everything. So running the model checker and giving feedback is there really important. And then languages are not enough, so we don't only build languages, right? We build a tool. So in the end, we don't ship a set of MPS languages to our users, we build a tool with a Chrome, with an integration, maybe into source control, whatever kind of model repository you use. Might be Git, might be Subversion, might be your own custom persistence, might be stubs built from something else. So the tool must integrate there, right? And have a nice looking Chrome, so remove some of the clutter from MPS. There are tools to do this. There's action profiles in the embedder, in the MPS extensions, where you can basically remove actions you don't want to see in the action system. It lately also allows you to customize the toolbars, and maybe even have different toolbars or action profiles based on also editor hints. So what we have, for instance, in one of these projects is 2 completely different views on the models. And apart from only changing the editor hints, they also change which action profiles are applied, which toolbars are actually configured, etc. So that each user group gets a more specifically tailored experience to what they actually do. and provide incremental updates, because nobody wants to download 500 megabytes of RCP every 3 weeks. And there's ways to do that. The IntelliJ platform basically ships an incremental update tool where you can just give it 2 MPS installations and will calculate the delta between the jars and ship only the delta to the end users. And this reduces the size dramatically. So when I talked about the project where we release every 3 weeks, so the whole RCP is 350, 400 megabytes, which is already small for an MPS RCP, but our incremental updates are 2 to 5 megabytes. Because it only ships the delta between the classes. This is quite helpful. Yeah, and your tool must integrate with existing tools maybe. So there is an existing tool landscape where you are one citizen in this tool landscape. So really think about how you can integrate with these things, how you interface with them. But it's not only about other tools, it's also about existing processes and workflows. So if you build a tool that doesn't support the workflow of your users, they don't care. They will not use it because it doesn't fit how they work. And this is more a thing where it's not really language design, etc. This is the part where you actually want to focus your usability research on, where you want to look at what's the context where your tool is used in, from an organizational perspective, the workflows, but also from an existing tool landscape. And you must also integrate with the user's mindset. If they do not have the same mindset as the one behind your DSL, they will not actually like it. They cannot use it because they don't understand what you are giving it to them. Of course, integration can here also mean you train them. If your user group is small enough, this might be viable. If your user group is hundreds of people, it might not be. So integration here can also mean training users if possible. Then, of course, there's also teams that play a role into this, especially team size. So there's quite some research out there that tells you small teams are more innovative than big ones. They might be moving faster, but they might also break things faster, so that's a thing to consider. There's no golden rule here. It basically depends on what you're building, right? If you are very early in your process, you might want, in your development cycle, you might want to have a very small team that basically builds things fast and ships them, but you might have later on the requirement that you can actually no longer break things and you need to have a much more stable thing that you ship. So there might be favorable to have a bigger team because people can cross-check the work of each other. But there's no golden rule here. There's the famous 2 pizza rule from Jeff Bezos, where he says if the 2 pizzas can feed the team, you should split it up. It depends, but in some cases it's really useful. Okay, then I will keep this quite short. So it's called dependencies and feedback, but it's actually about a bit different things. So thinking about what are the individual aspects of the thing that you ship. So on the one hand side, we have your language. And then we have models that are created from that. So your users that use your language basically give you feedback if it's the right thing they you built for them, right? But then on the other hand, there might be generators or interpreters involved that add some executable semantics to the things that the users model. And then there's an artifact generated from this or data produced if you basically interpret your models. And the feedback you get from the generated artifacts or from the interpreted results is fed back into the generator or the interpreter, and the language and the users of your model basically also hopefully talk to each other. And in the very ideal case, everything is owned by one team. So one team basically creates the models, it maintains the language, it maintains the generators, and it's also interested in a generated artifact. So the code that you get from it, you run it, you deploy it, you are the one who also owns the infrastructure around it. This is basically how most projects start. Everything is one team, everything is coherent, the feedback is fast, there are not even releases usually involved, because you directly talk to your users with the things that you build. Then, at some point, you most probably get to this. You still have the language, the generator, and the person who and the people who run the code as one team, but you might have a team of domain experts using your model, which are not basically part of the same organizational unit that builds the language and the generators. So here it's still quite easy because you only talk to your end users, you only get feedback from them. You release things and you get feedback on your language. That's all the other things you own. If you change something in the generators, you can also change the runtime where the code is executed, etc. But sometimes you end up with this. And this is basically the worst case you can have. Because this is a general purpose language. So in a general purpose language, you would have the same. You have a committee that standardizes your language and some code generator or compiler that you also don't write your own. On your own, you don't own it, you use it. But you are still interested in a generated binary, you won't run it, etc., right? And in one of the projects, we accidentally ended up with this. And the team who was using the model and was also owning the generated code was utterly frustrated. And we didn't actually understand why until we looked at this. Because we saw, okay, if they change the model and the language doesn't allow them something, they have to talk to the language developers. And one iteration later, they actually notice, oh, the generated result is not what we want to have, but we are still responsible for running the generated artifact. And we don't also own the generator. So they basically always had to wait a lot on the people who built the language and the generator. So this is really something to avoid if you can. And typically you can. And then in the end you might also end up with something like this. This is more like you have a standardized language in your organization, and then you have teams building generators and also owning the artifacts generated from this. So this might be, you have this distributed component model for your car, and then different departments write their own generator to get meaningful information out of these models. They also don't own the models because they are created by whatever software architects for the overall car, etc. But in this case, you have the generator and you also own the generated artifacts, so you are also quite independent. So one thing here is to think about the interdependencies between those individual aspects and if you can actually own them or not. So here it's really important that you can own the things you are also responsible for. So, and then two more slides. So everything of this might sound a bit familiar. So I have talked now 40 minutes without mentioning it, so we call it agile software development. So, and there is not much different from this when you look at languages. It's just you have to map these metaphors that you would do in Scrum, in Kanban, whatsoever, where people talk about how to do this with normal software development to languages. This is just the same principles applied to language development. That's it. Questions?
So you mentioned at some point that the mindset behind the DSL has to align with the mindset of the users. Can you give some examples where it didn't align?
So the question is, if I have examples where the mindset behind the DSL did not align with the mindset of the end users. Okay, so one example also from the distributed architecture modeling is where at some point you want to actually describe how the communication on the wire works between those components. And some part of the domain experts basically wanted to have this without any configuration. They said, oh, I just want to say use some IP, use whatever other communication protocol we have here, some HTTP RESTful things, and I don't want to actually specify anything else than this. But from a generator perspective, what should you do, right? You cannot really expect magic there. So the first thing, so we had this requirement, so the first thing we shipped was basically a way you just said, I want to export this interface to this protocol, and the generator would do all the magic behind the scenes, mapping the data types, etc. And we thought this was awesome because the users have to have less configuration, it's for them less friction, they just say, okay, this protocol, I don't care. But then our users came back and said, this is not what we want, we need to take into account backward compatibility to legacy interfaces that are already out there, we want to migrate them into a tool, so we had to change the language that the users actually have to specify exactly how each data type is mapped, because we didn't know that they have this mindset of backward compatibility or forward compatibility, that they might choose bigger fields on the wire to cope for future changes in the interface, for instance. Or that you have a language that is very that describes things in a very that you have. So one idea that we once had in this component modeling thing was also we have just everything as a big tree structure, and then you have one view on this, and this was what we thought would be the best thing for the end users, but they want to have it in a much more modular way. They want to describe maybe the software interface and the component that is using it at the same place, while we thought this is completely two different things of root nodes, for instance, in the language. But the users didn't think like this. They think like, I have my component and I have the interface for this component. Which is also not true because they instantiate the interface multiple times. But then over time we educated them, hey, we had this idea of being able to define the interface somewhere else and reusing it, but we had to guide them through multiple iterations until they really saw the value in that.
Thank you.
One more question? Okay.
You said you introduce features over time to guide people. How does this work with people joining the team, so the users team?
So the question is, how does introducing features over time to the DSL relate to people joining the users of the DSL? I mean, the good part there is you already have an existing team that trains the other people. So I never saw this as really a thing that we had in practice to consider, at least from the experience that I had. Because if you have already a user base who knows what is there, they typically are good at explaining it to other people joining this domain experts team. It might be a different thing from the language development point of view. If you have already a bunch of stuff, onboarding new people might be complicated. Okay, then that's it.